What's up, scholars? Today we're going to talk about trig equations. We're going to jump right into an example. All right, so here's our question. Find all angles between 0, including 0. That's what that less than or equal to means. It means 0 is possibly part of our answer here. Find all angles between 0 and 360 to satisfy the equations below to the nearest tenth of a degree, if necessary. All right, so I'm going to write that down. 10 tangent of B plus 12 equals tangent of B plus 6. First example. Okay, so at first blush, this might look a little bit gnarly, but we're going to treat this tangent of B as though it was an x. So we're going to say x equals tangent of B. So let's rewrite this equation. 10x plus 12 equals x plus 6. Well, this is a lot easier. So let's get all the x's on one side. So let's subtract x on both sides, and we'll get 9x plus 12 equals 6. And let's subtract 12 on both sides, and we'll get 9x equals negative 6. And we'll divide by 9 on both sides. Divide by 9. X equals negative 6 over 9, which can reduce to, if I divide both of these by 3, negative 2 over 3. Okay, so then let's resubstitute our tangent of B. So we have tangent of B is going to equal negative 2/3. And we know how to solve that because we did that all last lesson. And I ran out of paper, so I'm going to write that on the next page, that tangent of B equals negative 2 over 3. So we know we can take the inverse tan of both sides to get B by itself, inverse tan of both sides to get B by itself. Negative 2 over 3. So B is going to equal the inverse tangent of negative 2 over 3. And if I plug that into my handy dandy calculator, right, I want a second. So inverse tangent of negative 2 over 3, it tells me, nope, I did negative 2 times 3, try again. 10 of negative 2 divided by 3. All right, negative 33 point, what did it say, round to the nearest tenth. So we'll say negative 33.7. So B equals negative 33.7 degrees, which is going to put it negative 33 means we're going clockwise. Negative 33 here, negative 33 here. Great. I believe the question asked us between 0 and 360, and negative 33 is definitely not between 0 and 360. So I'm going to add 360 plus negative 33.7. And so this is 326.3 degrees. But we know that tangent is negative when either sine or cosine, but not both are negative. So we're going to have another answer in the second quadrant. Right? We recall quickly, here's our quadrants, 2, 3, and 1, 4. Remember, all of them were positive here, sine was positive here, tangent was positive here, and cosine was positive here, which means that tangent is negative in the second quadrant. Tan is neg here and tangent neg here. Okay, negative in the fourth and the second quadrant because all were positive in the first and tangent's positive in the third. So it must be negative in those two other places. Okay, great. So we're going to copy this triangle over into the second quadrant. So if I copy this triangle into the second quadrant, got my 33 degrees here. Okay, great. So I really need to know what this measure is going to be. So this would be not quite 180. It's actually going to be 180 minus 33 degrees. 180 minus 33 degrees to get, or 33.7, right? It's 33.7 degrees. So 180 minus 33.7 degrees is 146.3. So our two answers are 326.3, which we got from our calculator. We got negative 33.7, so we added 360 to get that guy. And to find the other one, we used the quadrants. We know tangent is going to be negative in the fourth and the second quadrant. Our initial answer gave us an answer in the fourth quadrant, so we need another answer in the second quadrant. So we redrew this triangle, got it, and found that this angle here would be 180 minus 33.7. Okay, now we could also use our Desmos, and you know that's my preference because I love the Desmos. So go over to Desmos and plot the tangent function and plot a horizontal line through where we want our answer to be at -2/3. And we're restricting our answers to between 0 and 360 or 0 and 2 pi. So we find intersections here at 2.554 and 5.695. And then we would convert those radians to degrees. Let me see. Convert. Yeah, there we go. There's our 146.3 and 5.695, 5.695. Convert. There's our 326.3. Great. Awesome. So let's go back into Delta Math, plug in our answers. What do we say? 146.3. And there's another answer at 326.3. Submit our answer. Survey says, ding, 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 ding. Excellent. So quick little recap of what we did. We had an equation. We replaced the trig portion of it with an x. So we said, let's say that tangent of b equals x. And this equation became much simpler. It said 10x plus 12 equals x plus 6. Solved for x, and then replaced our x equaling tangent of v to get that tangent of v equaled -2/3. Right, that was our simplified ratio. And we either use our inverse tangent, plug it into a calculator, figure out where that's going to be as one angle, and then use our chart to determine where the other answer is going to land, or we use our Desmos. Okay. So we're going to do one more example for the second type of question here. To solve the trigonometric equation for all values 0 less than x less than 2 pi. Okay, so this is an important distinction here. We are going to be working with radians, not with degrees anymore. So previously this was saying between 0 and 360. Now this is saying between 0 and 2 pi. That should indicate that our answers should be in radians. So let me write this guy down. 2 sine of x plus the square root of 2 equals 0. And let's solve it. Okay, let's do the same thing here. Let's substitute out this sine of x as to not be confusing. I'm not going to call it x, I'll call it a. So a will equal the sine of x. So our new equation is going to be 2a plus the square root of 2 equals 0. Let's get a by itself by subtracting square root of 2 on both sides, subtracting square root of 2 on both sides. So we have 2a equals negative square root of 2, divide by 2 on both sides, divide by 2 on both sides. We get a equals negative square root of 2 over 2, and then resubstitute our sign in here. So we have sine of x is equal to negative square root of 2 over 2. Not bad. And I'm writing with this giant handwriting, so I ran out of space. So let's put it on newspaper paper. Sine of x is equal to negative square root of 2 over 2. So to get x by itself, we're going to take the sine inverse of both sides. sine inverse of negative square root of 2 over 2. So we get x equals sine inverse of negative square root of 2 over 2. And what do I get when I plug that into my calculatrice? Inverse sine of negative square root, no, not squared, I want square root 2, nope, divided by 2. Love it, negative 45 degrees. So x equals negative 45 degrees. Where is that? Negative 45 degrees means we're going clockwise, means it's here. Great, there's our 45 degrees here. Awesome, which means this going counterclockwise will be 360 minus 45, which would be 315, I believe. Is that right? 360 minus 45. Yep, 315 degrees. Okay, great. So our sine is negative here. Sine is negative. Where does our other answer need to come from? Well, if sine is the y value, sine would be negative in the fourth and third quadrants because these have negative y values. So sine is negative in the third and the fourth quadrant. So I need to recopy this triangle into the third quadrant. I got 45 degrees here. And the angle is going to be 180 plus 45 degrees. 180 plus 45, which is 180 plus 45. 225 degrees. So those are our two answers, 225 and 315. And of course, we could answer this graphically. So let's check out what that would look like. You know what? I was just cruising on like nothing was different. I said these answers were going to be in radians this time because we were supposed to be between 0 and 2 pi, right? So answer should be in radians. Should be in radians. So we could convert these to radians without a problem. Definitely would not be an issue. Okay, so I've got my calculator, radians 2 degrees. Let's switch this. Let's make this degrees to radians. So we said 225. When we convert that, we're going to get 1.25 pi radians. And 315, 1.75 pi radians. Okay, got it. I feel like it's probably going to want these as a fraction as opposed to 1.75 pi. So 1.75 as a fraction, it's some number of fourths because it's the 0.25. So 1.75 as a fraction would be 7 over 4. So this is 7 pi over 4. And 225 convert 1.25 as a fraction is going to be 5 over 4. Okay, 5 over 4 would be our 225 degrees. But let's just go look at what it says on the Desmos, because you know that's the prettiest. On the Desmos, and in Desmos, it's already in radians, also nice. So I've got sine of x, and we want to equal negative square root of 2 over 2, and we're restricting ourselves to 0 to 2 pi. So I've got an answer here at 5 pi over 4, awesome, and 7 pi over 4. Excellent. So for these questions where answer needs to be in radians, it's really nice to use our graphical analysis tool. So let's go put in our answers of 5 pi over 4 and 7 pi over 4. Let's submit like a boss. Boom shakalaka. There we go. Okay, those are your two types of questions. So let's review what we did. Our first type of question, we were answering in degrees, but we had 10 times tan b plus 12 equals tan b plus 6. We substituted x in for tangent of b to make this equation nice and solvable. got down to x equals -2/3, and we resubstituted our tangent of b in for x. Then we used our handy-dandy calculator to find that b equaled -33.7 degrees using our inverse tangent function. And we knew that tangent is negative in the fourth and the second quadrant, so we recopied this triangle into the second quadrant to find our other answer. And the second type of question we did, answers needed to be in radians, which I almost forgot about. But the question said 2 times sine x plus square root of 2 equals 0. We substituted a in for sine of x as to not make it confusing with the letter x, and solved that for a and got a is equal to -square root of 2/2. And resubstituted sine of x back in for a to get sine of x equals -square root of 2/2. Then we took the sine inverse of both sides to get x by itself. So x equaled sine inverse of -square root of 2/2. Calculator told us that was -45 degrees. We found that to be 315 degrees and knew that sine is negative in the fourth and third quadrant, right? Our answer here negative. So we're looking for where sine is negative in the third and fourth quadrant. So we recopied that triangle into the third quadrant to find our other angle. But then our answer should have been in radians. So we said, hey, let's just go check out what Desmos had to offer. And we found that theta equaled 5 pi over 4 and 7 pi over 4. All right. That's it, scholars. Love you so much. Keep on that hustle. You're doing great.